Alright then, hello guys. Today we're going to be doing another Pwnable.kr challenge. And the challenge I'm going to be doing today is going to be called Coin1. So with this challenge, we're giving a netcap port. So let's get started. So if we click on this C and we press enter, we see we get a connection. Is that shall we play a game? You are given some gold coins in your hand. However, there's one counterfeit coin among them. Counterfeit coins look exactly the same as the real coins. However, its weight is different from a real coin. The real coin weighs 10 and a counterfeit coin weighs 9. Help me to find a counterfeit coin with a scale. If you find 100 counterfeit coins, you will get a reward. FYI, you have 60 seconds. So there's something for our notes for the most part is we know that we have to find control. We had to find 100 coins in under 60 seconds. Real coins are 10 and then fake coins are 9. All right, so we have that in our notes, and it says right here how to play. You get specific n coins and a number of chances. So then you get specify the index of the coins to be weighed. You get the weight information 2 or 3 repeated C times. You will give the answer. So in this example, we're giving 4 coins. We're giving 2 chances to try it. So what this person does, he enters 2 values, 0 and 1. And 0 and 1 are guessing are valid coins because both their weights are 10, and 10 plus 10 is equal to 20. So that's 10 right here, so this is a valid coin, and 10 right here because it's a valid coin, so it's 20. So that means 0 and 1 are valid. Then it enters 3. He enters 3, which is his second guess, which is also 10. So now since the server responded with 10, that means that for the most part that was a valid coin. And now the person enters 2, and then I guess it returned a 9, so that means 2 is the invalid coin. And I guess we could show it off right here if we just connect to it again, because the session expired because I guess we're giving a certain limit. So we have 993 coins and we're only giving 10 tries to try it out. So let's try it out. So we check out 0 and 1. So 0 and 1 return 20 because both of those values are valid coins. So let's try 4, 5, 6, 7. So 4, 5, 6, and 7 are valid coins as well because they also returned 40. So that means 10, 10, 10, 10. So that means these are valid. So let's try 8, 9, 10, 11. That's 40 as well. So, and there seems to be no limit what we could do. 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. That's 100. So let's try again. But let's try with 21, 20, 22, 23, 24, 25, 26. That's still valid coins because they're still like valid coins for the most part. And then we get time expired by because we're only giving 60 seconds. So that kind of makes sense. So what we want to do is be able to find a number that's not going to equal to 60 because there's only one invalid coin. And yeah, if you find 100 counterfeit coins, you have 60 seconds. So yeah, so we have to find 100 counterfeit coins and then you give the answer. So in this case, 2 was invalid because I guess it returned a weight of 9. So every time you enter a number, it returns the weight. If you enter one number, I guess it returns only one weight. And if you enter multiple, it just adds up the weights for the most part. So how do we do this? How do we solve this challenge? So I guess I'll show you my code for the most part. So what we do is basically, we could ignore this part. So we have 100 tries, so that's why I have right here 100 for every iron range of 100. So that means we go over it 100 times. So let's start right here. So first, we receive the line, which is right here, UN 317 and C9. This first number retrieves 317, and this first number returns the N value, and this number gets the C value for the most part. And then we print out N and C. And then what we're going to do is we're going to do something called binary search. So with binary search, if you guys don't understand what it does, binary search basically helps us speed up our process. Binary search is an efficient algorithm for finding items from assorted. Items in a certain. It works by dividing the half portions of the list that could contain the items. So why do we do binary search? Is because if we were to do a linear search, which is just checking every one of them one by one, versus binary search, we see that with a binary search, things tend to go back quicker, while with a linear search, it takes like 15. But if we were to think of this like values being put in, at 15 values being put in, we could do it like in 2 seconds. But in this case, 15 values right here takes 15 seconds. This is just an example if this was values in seconds. This is just an example how I would explain it. So with binary search, you see it's a lot quicker. This line is a lot lower, so that means it's quicker for the most part. So why would we do binary search? Is because we're only giving a limited amount of tries. Because let's say if we, for this example, we're giving 993 values, but we can only enter 10. So what does that mean? That means if we want to try all these values one by one using linear search, what it'll do is basically, for the most part, we're gonna have to have 993 tries, but we don't have that. We only have 10 tries to actually figure it out. In my case, I didn't lose tries, but my time expired, so that's the reason we use binary search. So if we go back to our code, so we have binary search right here. So let's see. So this is where, so we have a start, which starts at 0, and then n, which is n minus 1, which is n being how many values we have, and then minus 1. So then we do a for every range in C. So for every number in for every try that we do, because we're only giving a certain amount of tries. So for every try that we do, we have this. So to cast ensure only whole numbers. So this is just to make sure we only have whole numbers when we divide by 2. Why do we divide by 2? Is because with binary search, we have something called the start, end, and middle number. So I'll go back to this example. In this case, what we want to do with binary search is, what we're going to do is add up only, let me take out paint. And then fill this up right here. Okay, let's say we have the list 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we know that 9 is the fake number, or that makes it kind of confusing. 2 is the fake number. So what we're gonna do is basically have the start, which is 1, equals start, and equals 10, and then mid is equal to, I think, 5. I think we just do, let's add this 0. That makes it a lot easier. 0, 10, and then mid is basically 5. So what we're gonna do is basically add all the numbers from start to mid. We're gonna add all the numbers from start to mid, and you know that if it's a valid number, then it's gonna be something like 70, or like from start to mid, that's like 1, 2, 3, 4, 5, and 6. So that's gonna be 60. And since 60 is, if you could divide it by 10 and there comes out no remainders, so if you do modulus 10 and it comes out to like 0 because there's no remainders, that means for the most part that, oh no, but in our case 2 is a fake number, so it'll probably be like what, 10, 20, 30, and then 30, 30, 39, 49, 59. So it'll be 59. 59. And then 59 modulus 10, that's going to come out to 9. And since that value, and if that is not 0, that means that our end value can shift. So that means our end value shifts. So now 0 is equal to start, and end is equal to 5, and then mid is probably going to equal to probably 2. So what that means is basically, if you just copy this again, 0 all the way to 5, 6, 7, 8, 9, 10 get eliminated because we know that our number is between 0 and 5. And next thing you know, we repeat this pattern over again. So then we know that, if I could scroll down here or just kind of shift this. If I do something. No. No, okay, so I guess I can't shift it like that, but so now our start and end is 5 and mid is 2. So that means if you go right here and click right here, so now we know that. So yeah, now we know 0, 1, 2, 3, 4, 5. 0 is equal to start, end is equal to 5, and mid is equal to 2. Now we know that. So now we get to cut it in half again. So now we check start to mid again. Start to mid, and that's going to equal what, to 39. And then that by modulus 10 is equal to 9. And if that is not 0, then that means that our end value shifts. So now we know that. So our start is equal to 0, mid is going to equal to 1, and then end is going to equal to start. Now we do the same thing over again. So now we do a start. Now it's going to be 0, 1, and 2. And we do it again, start to mid, and that would start to mid, and that's what, 20 modulus 10 and equals 0. If it's equal to 0, then we shift it, then we shift our start. So now, since that's true, that means our start gets shifted. So now it becomes something like this. So our start now equals to mid. So start is equal to mid. And I guess mid is still gonna equal to start. Everything's gonna point to that, and then end is gonna equal to mid. And that basically means that for the most part we found our odd value out, and that only took how many tries? So that's 1, 2, and 3. That took us 3 tries. Compared, if we were to comparing it 1 by 1, which would take 2 tries because we're going 1 by 1. But worst case, if let's say worst case it was up to 9, worst case up to 9, it would take us 9 tries. But with this, it lowers down our tries. So now we know that. So now if we go back right here, that's basically what I do right here. Basically get the mid value, and after that, this is basically just a Python notation. It just starts from the start and all the way to the mid plus 1, and we just get a list of all those numbers, and I'll print out print out the guess right here. So just go down right here, print out the guess, and then we send it, and then after that we receive the weight, and that's gonna be the weight of the added up of all the numbers. Now, like I have said here, we have our logic. If it equals to 0, then that means there's no counterfeit in that list. So that means we just shift our mid value to something else. Else, if the counterfeit is in the list, we shift our n equals to mid. And then at some point within this code, we end up finding the counterfeit. And after that, we just send in our value at the end, which is going to equal to start. And after that, we print out the correct value. And after that, it prints out the correct, you get your flag, and then correct, you get your actual flag value. So let's get started. So if I run this, and I guess one thing to be sure is that this code up here, for the most part, it was basically to SSH connect to it. Because if we were to do this from the outside, if we were just to connect to it like using remotely, like in this example, it will take a lot slower. So it said, I'm pretty sure inside the thing, if your network response time is slow, try and see inside the Pwnable.kr server. So try connecting through inside the Pwnable.kr server, which is what we're doing right here. So we SSH, and in SSH we just do a remote host. We connect to the remote network using netcap. And that's basically it for this challenge. And I'll show you guys an example. So we'll do Python 3 solve.py. And right now it's solving it. So it's connecting. Yeah, it's okay. We check right here. Okay, so let's see an example. We have 705. So 705 is divided by half, which is 352. 352 times 2. That's what? Calc. I'll just 705 divided by 2. 352. We got that. Now we have numbers from 0 to 352, and it added up to 3529. So that means the counterfeit number was inside here. So since the counterfeit number was inside here, all we need to do is shift our end value to our mid, and then after that we find the next mid value. So we know 352, it's within this range. So this is our start. It starts at 0 and it ends at 352 now. So now we divide 352 divided by 2, since it's between these two. So divided by 2, that's going to be 176. And if we check right here, it's at 176. And we see that it's 170. So that means from 0 to 176, the value is not there. So that means it's probably gonna be 177 to 352, in which you see right here 177 to 177, 263, 260, 26478. Okay, this, oh no, yeah, I guess 263 in this case. I guess I found the other half. So 177 to 263, unless the code kind of messed up for the most part. 220. So it's between these two values now. So 177 between 263, and then I guess I found the value right here. So now we divide this value by half again, and from 177 to 220, and we see it's 439. So that means it split it even more. So now 177 to 198, which is half of this, which is 219. So that means it's between these two numbers, and we check this half, and you see it's 110, so it's not that. So it's gonna check 187 to 187. I guess it's gonna check 177 to 188 to 193. I guess this half. Oh, because it starts at 198, and then we want to check this half, and then see it's 59. So that means it's gonna check this second half, and it does, and it's 30. So it's gonna check 190 to 191, and then we say it gets 19. Then it checks one of these values. It's not 191, so we send in 192, and after that it passes in, and we get the correct answer. So it does this for every one of them, because it gives us, I guess, we have to solve this 100 times. So this is going to be a new number right here. Now this time it's from 821 to 10, and we're giving the range of numbers now. So 821 divided by 2 is 410, and then just go and do the same process all over again. And we see right here that's being called, and right now I paused it for a bit, but if we press enter again, we see that at the end we said correct congrats, you get your flag, and then we get binary search string is easy peasy. So technically you could just copy this for the most part and just submit it, and then you'll solve this challenge. So if I just submit it right here, I probably can't submit it because I need to log in, but if you submit it, log in first. Yeah, but anyway, that was about it for this challenge. It was pretty much understanding how binary search tree works. Hopefully you guys learned something new. I know I did, about understanding how binary search tree works. But anyway, that's about it for me. Peace.